In this math tutorial, we'll be having a look at multiples, factors, and prime numbers, how they are connected to each other, and how do we work out the multiples of a number or factors of a certain number. Why is this important? Because in mathematics, whether we're using basic arithmetic or we're using algebra, we will be required to either work out or identify multiples or factors in order to simplify efficiently and also factorize correctly. Let's jump in. Let's have a look at multiples. This is by far the easiest thing to explain. Multiples are literally the multiple of a number. We count within the number. If I have, for example, the multiples of 2, then that would be 2, 4, 6, 8, 10, etc. Think of your times tables. If I have the multiples of 13, then I have 13, 26, 59, 52, etc. So that is what a multiple is. Factors, on the other hand, factors are special because factors are numbers that can divide exactly into themselves. No remainder. This is very, very important. For example, if we work out the factors of 6, we'll notice that would be 1, 2, 3, and 6, because 6 divided by 6 is 1, 6 divided by 1 is 6, 6 divided by 2 is 3, and 6 divided by 3 is 2. Same for something like the factors of 18. This would give me 1, 2, 3, 6, 9, and 18. Now, how do we work out factors? How do we get to factors? Well, with a few simple, easy steps. Let's determine some factors in order to see how this works. Now, this is my method. I like to use this method. It's the most fun method to use for me. So let's determine the factors of 24. I like to work with a number line. So I'm going to draw my number line, and then I'm going to say that my first factor pair for 24 would be 1 and 24, because 24 divided by 24 is 1, and 24 divided by 1 is 24. So that's going to be my starting point, my lowest factor, and my highest factor of my number. Now I'm going to start asking myself very important questions, 3 questions to be exact. I'm going to ask myself, can the number be halved? If it can be halved, then it means that it is divisible by 2, and that's my next factor. So 2. And I know that 24 divided by 2 will give me 12. Now I'm going to apply my division rules or my divisibility rules. And here I'm going to say, okay, 2 and 4, if I add 2 and 4 together, that will give me 6. 6 is divisible by 3, meaning that 3 will be my next factor, and 24 divided by 3 will give me 8. Now I'm going to continue with my rules. 24, 4, the unit 4 is divisible by 4, so 4 will be my next factor, and 24 divided by 4 will give me 6. Continuing with my divisibility rules, you'll notice that there is no other number here, not 5 and 6. Okay, well 6 is, but 6 I already have. I've already got this factor or this number on my number line. When that happens, I've reached my halfway mark and I can stop calculating factors. So halfway mark, did I reach it? Yes. Remembering that the halfway mark is when you start getting numbers you already calculated. And there we have it. The factors of 24 is 1, 2, 3, 4, 6, 8, 12, and 24. Let's determine the factors of something a little bit more bigger, like 64. First, I'm going to draw my number line, and I'm going to set it up by placing my first factor pair, 1 and 64, since that will be my lowest factor and my highest factor of this factor group. Now, I'm going to start asking those questions again. First question would be always, can the number be halved? Then, yes, it can. 64 can be divided by 2. So my next group will be 2 and 32. Now I'm going to continue working out my factors by using my divisibility rules. 3, no. 3 cannot divide by 64 since 6 and 4 added together is 10. 4, yes, because 4, the unit in the number 64, can be divided by 4. So my next factor group would be 4, and 64 divided by 4 will give me 16. Continuing with my divisibility rules, I'll notice that 5 cannot be divided, but 6 can. 6 can. So 64 divided by 6 will give me 8. 7 can't. So, and once I've reached 8, which was already on my number line, I've reached my halfway mark, meaning that I'm done working out my factors, and the factors of 64 is 1, 2, 4, 6, 8, 16, 32, and 64. Now let's have a look at something like determining the factors of 65, 1 unit above 64. Setting up my number line, I'm going to have my smallest and largest factor first, and that we know will be 1 and 65. Next up, I'm going to start asking myself the 3 questions. I'm going to ask myself, can the number be halved? In this case, no. And then I'm going to apply my divisibility rules to work out the other factors. And then I'm going to look out for my halfway mark. So 65 cannot be halved. Can it be divided by 3? No. 6 and 5 gives me 11. 4, no. 5, yes. So my next group will be 5. And 65 divided by 5 will give me 13. Now, if I follow my divisibility rules correctly, I'm going to end up with no other factors until I reach 13. 13 is my halfway mark because it's already on my number line, and thus I've gotten all my factors: 1, 5, 13, and 65. Let's determine the factors of 213, a bigger number. Okay, so I'm going to start again, drawing my number line, placing my smallest and my largest factor first, 1, and the number itself, 213. Now I'm going to ask myself my 3 questions again. First question will be, can the number be halved? In this case, again, no, it cannot be halved. I'm going to apply my divisibility rules, and then I'm going to watch out for my halfway mark. So since 213 can't be divided by 2, I'm going to move on to 3. 2 plus 1 is 3, plus 3 is 6. Yes, it can be divided by 3. So my next group will be 3, and 213 divided by 3 will give me 71. Now, sometimes we are going to get a number that is a little bit more complex, and we're going to work out factor upon factor upon factor, and we're not going to get anything. This is one of those cases where 71 will be my halfway mark. So the factors of 213 will be 1, 3, 71, and 213. Let's have a look at what is a prime number. A prime number is a number with only 2 factors, 1 and itself. Now, if we have a look at the factors of 213, 213 is not a prime number because it has more than just itself and 1. But 3 and 71, those 2 numbers that we've gotten, is prime numbers. Since 3 can only be divided by 1 and itself, 1 and 3. And the same goes for 71. 71 can also only be divided by 1 and itself, 71. In the case where we had with 65, here we know that 65 is not a prime number since it has 4 factors. But 5, again, is a prime number since it can only be divided by 1 and itself, 1 and 5. 13 as well. 13 is a prime number since it can only be divided by 1 and 13 or itself. You'll notice that I've mentioned that 1 is not a prime number. Why is 1 not a prime number? 1 is a unit, the first unit. And the definition of a prime number is that it has to be a number that is greater than 1. If it's not greater than 1, if it's 1, then it's not a prime number. Now let's work out the ACM, LCD, or the ACD. What do these abbreviations mean? ACM stands for smallest common multiple, LCD stands for lowest common denominator, and the ACD stands for the smallest common denominator. All these things mean exactly the same thing. We're going to get the smallest or the lowest number, which is common, in the multiples for two numbers. Let's go see how we do that. Let's determine the ACM, or the smallest common multiple, of 9 and 12. I'm going to work on a number line. I'm going to first write down the multiples of 9 and the multiples of 12. 9's multiples, 9, 18, 27, 36, and so on. And 12's multiples are 12, 24, 36, 48, 60, and so on. Now I need to go and find the smallest common multiple found in both these number lines. And if I look closely, the smallest one, which is common, is 36, meaning that the ACM, or the smallest common multiple, of 9 and 12 is 36. Let's determine the ACM of 4 and 21. Again, I'm going to work with my number line, and I'm going to write out my multiples of 4 and multiples of 21. Now, in some cases, we are going to be required to write out a lot of multiples in order to get to the common multiple. In this case, we'll notice that 4, since it's a smaller number, will have a lot of multiples, and 21, not so much, but finding the common multiple will take a little bit more time, and we'll see that in this case it is 84. So the ACM of 4 and 21 will be 84. Now let's have a look at the GCF or the LCF. What does these abbreviations mean? So it stands for the greatest common factor or the largest common factor. And again, both these terms mean the same thing. We need to find the largest or the greatest factor between numbers that are common. Let's determine the GCF of 9 and 12. Now, I'm going to use my number line again, but this time I'm not going to work with multiples. I'm going to work out my factors using the factor rules. So the factors of 9 and 12, of 9 is 1, 9, and 3, and of 12 is 1, 12, 2, 6, 3, and 4. Now we need to find the greatest number, the largest between them. So in this case, it will be 3, meaning that the greatest common factor of 9 and 12 will be 3. Now let's work out the GCF of 112 and 16, a larger number and a smaller number. So again, using my factor rules, I'm going to work out the factors of each number. The factors of 112 will be 1, 112, 2, 56, 4, 28, 7 and 16, and 8 and 14. The factors of 16 would be 1, 16, 2, 8, and 4. The greatest common factor between these will be 16, meaning that the greatest common factor of 112 and 16 will be 16. Now let's determine the GCF, or the greatest common factor, of 65 and 213. Again, using my factor rules, I'm going to determine the factors of 65 and 213. The factors of 65 is 1, 65, 5, and 13. And the factors of 213 will be 1, 213, 3, and 71. So the greatest common factor in this case, since no numbers above 1 is common, is going to be 1. So the GCF of 65 and 213 will be 1. Now, let's see if we can combine these two methods to work out the smallest common multiple a little bit more easier. So in this case, I'm going to combine both my working out of factors and a little bit of the multiples in order to get to my answer. Let's determine the smallest common multiple of 9 and 12. Now, without having to write out my multiples, I can go and determine my factors first. So I'm going to determine the factors of 9 and 12. The factors of 9 is 1, 9, and 3. The factors of 12 is 1, 12, 2, 6, 3, and 4. Now, I'm going to determine the greatest common factor. We know that that is 3. So the GCF of 9 and 12 is 3. Now, I'm going to take my two numbers, 9 and 12, and I'm going to multiply them together, and I'm going to get to 108. Now I'm going to divide 108 by the greatest common factor, and I'm going to get to 56, which is the smallest common multiple of 9 and 12. And that's the gist of working out the greatest common factor, the smallest common multiple, and also the definitions of multiples, factors, and prime numbers. If you find this useful, please remember to like this video, subscribe to my channel, and comment on how you found this useful. Thanks for watching.